Okay, welcome to this session on the J Champions Conference, and I'm very pleased to have Antoine here, which is going to tell us some history about J2EE, about Spring and Quarkus and Jakarta EE and whatnot. So I'm really looking forward to this talk, and I hope you will ask a lot of questions in the chat, and we will have a chat with Antoine towards the end. So.
Okay. Thank you,
The
Ivar.
stage is yours, Antoine.
Thank you. So let's get started. I'm gonna launch the slide. So welcome everybody. So the talk today will be about the story of the Infinity War between Spring and J2EE, and we will see if it will come to an end game. In fact, J2EE is a bit old, isn't it? Perhaps it should be something like that for a title slide. So will the Infinity War between Spring and Java EE will come to an end game? Yeah, but lately we changed the name of the stack. So let's talk about Jakarta EE and Spring War. So let me introduce myself. Since I'm talking today here, I'm a Java champion. I'm a Java expert. I've been working on Java for more than 20 years, 25 years now. I'm a tech lead and architect in a small company called Siam. And I used to work at Red Hat. I've been working at Red Hat for 7 years. And I left Red Hat 2 years ago. And I was the former CDI spec lead for CDI 2, CDI 3, and I was part of the working group for CDI 4. So I will talk about a little bit about that. So you can follow me on Twitter. And I will make a little hat from my company, and it will be over after that. So Siam, my company, is a French IT and consulting company. It's based in Paris, and the company is only working on strategic mission. So it's only driven by challenge and mission that we can decide the architecture and the components of the solution directly. And we have experts from all over the world. So as you can see, from France, North Africa, Ukraine, etc. And if you speak French and you want to have more information about what we did on Siam, you can check our blog with the link here. But enough with the advertisement. Let's start with the agenda of the session. So this session will be mainly about history of Java for the enterprise with Jakarta EE and Spring history. We will start with a little introduction. I will explain why I'm giving this talk today. And after that, we will go through all the steps of the history, starting with the early ages. We will see how Spring was created, why it was created, and how it was created, and the consequence of this creation. We will check a few battle between both sides in the vicissitude of war section, to go to the microservice era and see how both stack adapted to this new challenge, to finish with the current era with the cloud war we are living right now. So let's start with the introduction. So why am I giving this talk? The best summary for the reason of this talk is probably the subtitle of this slide. So the people that fail to learn from history are doomed to repeat it. In my current job at Siam, I'm giving a lot of technical interview to recruit new developer, new expert. And I realized that most junior developer were only Spring devs. That's not a problem. But they didn't have any knowledge of the Java EE or Jakarta EE existence. They see the world through the Spring perspective, and they even don't know, for some of them, that they are using a part of J2EE with the specification like GPA, for instance, and they mixed specification and implementation. So when you start digging in the knowledge and the culture of those, you understand that they are not very clear on the the origin of the technology they are using. Okay, they can work without this knowledge, but I think it's better to know where you come from to be efficient in your work. And the last reason for me to give this talk today is because I was a witness of this history, and I was a very modest actor of this story when I was in the CDI specification. So before we deep dive in the talk, I think it's a good thing to say what is not in the talk. So you will know what you won't take away from this talk. So there won't be code example. I don't have enough time to show you stuff like that. Perhaps later I will do a blog post to have a more more detailed example on what was the J2EE code looking like, and Spring 1 code looking like, etc. There won't be any total objectivity, to be honest. So it's my vision of the story. And there won't be any trolling in the talk. Well, let's say that I will attempt to have a balanced trolling and give some blow on both sides. So now it's time to start and check the timeline of the major event of this war. So we will, during the session, we will go through most of the steps, but I think it's a good thing to have this overview of all the big, the big event of this battle between both stacks. So J2EE1 was released in 1999, and a few years later you got the first version of Spring released, and in response to the Spring release there was the Java EE5 with the introduction of the EGB 3.0. It was a very big change, in the stack. I put the Java EE6 because it was the introduction of CDI, and CDI is, I think, more a contender of Spring than EGB, even if Spring didn't acknowledge that at time and not yet today. And we will go through the 2010th and go to Spring Boot release, which was a game change also, with the microservice era in the Java world with Spring Boot. The answer on Spring Boot, it's my vision, was made with microprofile in 16th. And 3 years later we had Quarkus, so now it's 3 years ago now, more than 3 years ago. And at the end of last year, we had the introduction of Spring Native, which was an answer to the Quarkus introduction. Let's check the forces involved in this war. So on the left, you have all the cloud of actors in J2EE side, on the J2EE side, with a lot of big name like Oracle, IBM, Microsoft, Red Hat, and a smaller name but very efficient one like Tommy Tribe, Apache, or Payara. And you see that all these guys work together to define specification, to define how the specification should work together, etc., etc. And on the right side of the slide, you see the organization of Spring, which is more, ordered. The organization, Spring, is owned by Pivotal, which is owned by VMware and which is owned by Dell. But everything here is more focused on the target and less discussion. So perhaps it's one of the explanation of the success of Spring today. Regarding the implementation of both solutions, so you have I didn't put every implementation on the left side. There are more than that, but you see you have the Glassfish, the Open Liberty, Wildfly, Payara server, Tommy, etc., etc. So there are a lot of solutions based on Java EE, compatible with Java EE. So it's one of the big force of this side and of the stack. You have a lot of choice when it comes to choose an implementation of Jakarta EE. And on the right side, you have Spring. So one implementation, one decision, one flavor. And to continue on the little joke I did at the beginning, so the names and brand. So on the Jakarta EE side, you had three names: J2EE, Java EE, and now Jakarta EE. And there is no JEE for those writing and reading this. It doesn't exist. And on the right side, you have Spring. So let's start with the early ages of this Java for the enterprise story, and let's start with the Java down. So the work on Java started in the early 19. The first name was Oak, and it became Green, and Java was released at last in 1986. And very rapidly, people at Sun, at the moment it was Sun that was leader on the Java and owner of the Java trademark and platform, feel that they need to have something more than just the language and the JDK. They need something more enterprise oriented. That's the reason why, after a few attempts, the Java 2 Platform Enterprise Edition, J2EE, was released. So the first one that took momentum and was really used was the 1.2 version. And this first official version was only containing 10 specifications. So today, I think that Jakarta EE has around 30 specifications. So we see that there was a lot of work done in the 20 years. So this version of Java for the enterprise was released, and very soon there was some complaint about this platform. So you can read the blog post at the time, etc. But most of the complaint were related to application servers that were rather heavy and very slow to start, slow to stop, slow to deploy, etc. And very memory consuming and CPU consuming. There was also some complaint about the programmation model that was inconsistent. So when you were doing some servlet, it was one programmation model. When you were doing some AGB, it was another programmation model. And programmation model of the AGB was very criticized. And at the beginning, also some spec had a very large dead zone that led people creating the implementation to imagine how this dead zone should be filled, and there was a lot of incompatible implementation. So the promise to have a stack with a bunch of spec and interoperability between every implementation was not there. So this promise was not there, and you had a very heavy solution to deal with. But perhaps the specification that concentrate the majority of critics was AGB. AGB required a lot of configuration, and their code was totally coupled with the underlying framework. Donc you had to implement specific class or extend a specific class or implement specific interface, sorry, to use AGB. You also have a lot of configuration in XML file to work with them. So all these critics lead some people to bring an answer. So the most famous answer is probably Spring. So Rod Johnson decided to answer to this J2EE cumbersome with 2 books. So it starts with a first book giving some design and pattern and way to develop on J2EE, etc. And in this first book, give a lot of explanation about the limitation of the EGB. And after that, a few years later, but it was very short, 1 year or 2 years, he wrote another book giving a way to develop on J2EE without EGB. So in fact, in this book, it tells and it explains how to get rid of EGB, which was, according to him, the bad part of Java, of J2EE, sorry, at the time. During this period, with a bunch of other people, he started the development of a framework. So this framework was targeted to integrate the good J2EE part, so nearly everything except the EGB. And this framework was released in 2003, and it was Spring 1. So let's check how Spring took momentum and the consequence of this momentum. So Spring was since the beginning sold as J2EE as it should have been. So it was very aggressive way of releasing this framework. So if you read the first documentation of Spring 1.0 documentation, you see that a lot of arguments against J2EE are in the documentation, in the introduction. So it says that Spring brings an elegant solution to most of the J2EE issue. It also provides an unified programming model. So the IOC approach, so using the IOC pattern and loose coupling was a way to bring a cleaner code and hides all the magic in the configuration file. Okay, at that time it was XML. And this IOC pattern was one of the big points that will allow to provide a kind of consistent programming model across all the platform. And on the implementation side, Spring is probably one of the first Java framework to heavily use bytecode manipulation. So all the magic done in Spring is based, in fact, on one design pattern, mostly at the beginning, the proxy design pattern. And those proxies were generated and are still generated at runtime with bytecode manipulation. So roughly, for people that don't know this kind of stuff, you have frameworks that take your class, create another class that mimic your class, so is in the same hierarchy, but with all the enhancement of the Spring framework. And at runtime, this class created by the framework to take place of your original class. And month after month, Spring gets momentum. And you see a nice ecosystem that starting to flourish around it. So I was a young developer by then, rather young developer, and I witnessed that, and I was amazed at the powerful of the framework, and to see all the third-party editor and or solution developer developing their integration with Spring framework. Okay, so after the Spring release and the big critics of the AGB, on the J2EE side, there was a lot of discussion and a lot of work to provide an answer to that. So that leads us to the Java EE5 release in 2006. So the major feature in Java EE5, it's not the only one, but the major feature is probably the fact that AGB is totally rebuilt. In the meantime, you had the release of Java 1.5 introducing the annotation. And the stack is using heavily the annotation, and AGB3 does a lot of use of annotation. So it's still backward compatible, of course, but a new way of declaring AGB and developing AGB is based on annotation. So as I said in the slide here, it provides the same component that the previous version, but now you have a programming model that is now completely loose coupled thanks to annotation. So you don't need to implement a given interface or extend given class of the framework to have your components working. And I want to make a focus on that. After the release of the Java EE version, Red Hat, JBoss, did an interesting work to provide a new layer on top on Java EE that were able to use the AGB and to ease the integration of the AGB with a web application and a web tier. So it was JBoss SIM. So SIM is, I think, rather important in this story, even if today nobody remembers it, because it was the ancestor of CDI. So it's important to me, at least. So JBoss SIM was a great framework. I loved it. It was designed to play a role similar to a Spring framework, but in the Java EE sphere and with Java EE as a target. It provided an unified programming model, so it also used the concept of dependency injection and inversion of control, like Spring did, and it was also dependency injection based on ID and not on type safe like we have today in CDI. And it was a nice way to link AGB3 and web application But SIM also provided a way to have your own bin. You don't have you weren't forced to use AGB. You could define your own component, and the framework came with a nice ecosystem with a lot of integration of third-party technology and features like, I don't know, integration with reading Excel file, writing PDF, managing automatically mail, etc., etc. And it also provides Spring integration. So through SIM, the Java EE side acknowledge the importance of Spring and propose a way to unify Java EE and Spring through this framework, JBoss SIM. So it was a way to bring a universal solution and to have a way to bind all these enterprise level solutions. That was rather nice and rather working. I made some development with this solution. It was working. And SIM was very successful. We don't remember now, but it was a very successful framework. And that's the reason why Red Hat decided to start the CDI specification that took a lot of ideas from SIM, and but did a few changes that were how to say very damageable for the SIM ecosystem. So I didn't put any date in the previous slide, but this framework JBoss SIM was released around 2005-2006, just after Java EE5 release, and very rapidly there was work starting on CDI. There was a lot of work on CDI, and the specification was ready and was released in 2009 with the Java EE6 version. So CDI was and still an answer to the Spring core, but it came 6 years after the release of Spring. Perhaps it was a bit too late. It provided a strong type injection. At that time, Spring was not very strong type oriented. The AutoWire was only beginning, and I don't remember that they used annotation very early. They wait for that. So the configuration of CDI started with annotation, and there is this nice part of the spec providing a portable extension that allowed framework integration in a very nice and easy way, in a seamless way. But CDI is only an engine. There is no ecosystem, and it's not the target of the framework. Let's check some battle in the war that weren't very nice in the way they were led and the outcome of them. So Spring gave some low blows on the Java EE part. At that time, a few years after the CDI 1.0 release, I started to work on CDI 2. And I tried to discuss with the Spring guys to see how it could be aligned on CDI spec, or how we could add stuff in the @inject spec that was more or less led by Spring, and we didn't find an agreement to have the discussion. So it was not very a very nice exchange on that. During the CDI 1.0 spec work, Spring side brought the at-inject specification, as I just said. It was done very late on the Java EE6 part, so it made the Java EE6 release 6 months late, and this spec, to be honest, to be honest today, is rather useless. It doesn't provide any useful content, and right now Spring is still implementing it and CDI is implementing it, but there is not enough content in this specification to be really usable. It's only a difficulty for a CDI to keep this spec compatible with the CDI spec. So it's not a big present. It's not a nice present that Spring guys did to Java with that. At that time, and I think it's still the case, Spring worked on some spec. So I can think about the servlet spec. And they did what they can to limit CDI integration. So for instance, we try to give to the servlet specification some automatic bin related to servlet integration with CDI, because it was on our side and it was not very consistent to have those front component in CDI specification, and we didn't achieve to move them to servlet, mostly by the Spring vote on the servlet side. And another point that I think that's a bit pity is the fact that Spring never acknowledged CDI existence. So if you read all the previous documentation, AGB is mentioned in a very late documentation. I don't think the last version mentioned them, but in Spring 2 and Spring 3, I guess it's still there. And so AGB was always mentioned, but CDI was never mentioned in the documentation. So there was never, how to say, plan to integrate with the CDI and the Java EE. On the Java EE part, so I will only talk about Red Hat part, because I witnessed them. There was, I think, some error, but it's easy now from 10 years later to say it was error. I think the way they deal with the SIM framework was very damageable. It was a waste. To summarize this, in fact, during the CDI specification work, all the evolution of the SIM framework was freezed, and people were waiting for a new feature, bug correction, etc. But the people working on SIM were working on CDI, and they were saying, okay, so wait, we are working on a new feature. You see a new version of the framework which will follow a specification, etc. And you will see we will make all the features you love in SIM in this new framework. But it wasn't the case. It wasn't the case because first, CDI was very different from SIM on the core way of injection. So CDI is based on type-safe injection, and SIM was based mainly on identifier injection, like was Spring. And there was this initiative to bring compatibility from the former SIM framework to a new stack based on CDI. So it was the SIM-free initiative, but for a lot of reasons and a very a stupid reason, it wasn't possible to provide this backward compatibility, mainly due to the fact that the package name of the SIM3 was the same as SIM2. So it was not possible to identify the class that were coming from the old version and the new version. It could have been sorted out, but it was very hard to go that way. So that's one of the reasons why the SIM-free initiative was left over. But in SIM-free, there was a lot of ecosystem integration with third-party solution. So like I said, a solution with office integration, with mail transaction, with BPM integration, stuff like that. It was rather powerful and nice. And when the SIM initiative was closed, all this ecosystem was thrown away. So after this initiative, we had a nice way to work on dependency injection and programming model very efficient, etc. But with nearly no ecosystem. And compared to Spring, that have at the time a lot of third-party developer that worked to create the integration with the programming model of Spring. That leads us to the microservices era. So in 2014, Spring launched Spring Boot, and it's a game changer. It's a new way to use Spring with a lot of automatic stuff, magic stuff, with a lot of convention over configuration stuff. And it encounters a very successful feedback from the community. So it allowed to create standalone application, so you can use them on the desktop, but in fact it was also targeting the microservice sphere. And it adds a lot of, as I said, a lot of magic and assume a lot of default approach. After this first, how to say, wonder gaze on the framework, there was a lot of, how to say, less amazed feedback and more critics feedback on what Spring Boot was doing when you try to do a very, how to say, more real work and more advanced work. But nevertheless, it was a very nice release, and Spring Boot is still very used today. So the microservice era is probably one of the most interesting era of this war, because seeing that Spring Boot was taking momentum, most of the J2EE committer, J2EE spec expert and editor decide to launch a new initiative. So this initiative was MicroProfile. So MicroProfile was launched around 2016. It is a way to provide a specification, stack specification for the enterprise microservices. It was launched at the Eclipse Foundation. So there was a working group at Eclipse Foundation. And all those guys you see on the slide were part and are part today. Not of all were part at the beginning, but are part of the MicroProfile initiative. So if we look at what is in MicroProfile, so you see here not the last version, I will show you it right after, but just the previous version of MicroProfile, MicroProfile 5.0. And if you look at the bottom of the slide, you see that all the bottom specification used by MicroProfile are CDI, JSON-P, JAX-RS, JSON-B, and Jakarta annotation. So all those are coming from J2EE, Java EE. And so microprofile is compatible with Jakarta EE in some way. And on top of those, new specifications were added to provide a way to deal with microservices in the Java world. So the health check, metrics, fault tolerance, etc. Configuration, which is a very interesting and important one. And the spec governance decided to adopt another way of dealing with the release, to have something more fast-paced than the Jakarta EE release was, and provide a way to have a new specification. As you see on the right side of the slide, you have specifications that are not totally integrated in the official spec. They are waiting to be integrated, or they are not targeted to be integrated, but they stay here as a, how to say, companion specification. And between the launch of the microprofile initiative in 2016 and now, there was evolution of Java EE, which became Jakarta EE. I won't summarize the reason why it came here, but Oracle gave the code to the Eclipse Foundation. And if you look at microprofile today, you see that all those specifications that were at the bottom in the previous slide, if I go back, you see the CDI, JSON-P, JAX-RS, JSON-B, etc. In the last version of microprofile 6 that was released a few weeks ago, these are replaced by a new profile in Jakarta EE 10. So you see that Jakarta EE, in some way, provided how to say, a convenient version of the spec to allow microprofile to be more compliant with the Jakarta EE. So in Jakarta EE, you used to have two profiles, the web profile and the full profile. And the last version of Jakarta EE 10, introduced a core profile to introduce all those specific to group all the specifications that are the cornerstone of microprofile in one given profile. So it's still a CDI. Now it's CDI Lite. There is a version of CDI which is lighter than the CDI used to be. Still JSON-P, JSON-B, annotation, interceptor, REST, and the infamous @inject specification, which became dependency injection specification. So yeah, to make a small focus on microprofile, I think it was a very nice idea and very nice initiative. We should wonder why it didn't took more momentum than that regarding to Spring Boot. I think that first Spring Boot was probably more consistent, and it was earlier. And I think a second reason is probably that most of the vendors that implemented microprofile started their implementation with their Java EE server that they downsized. And in fact, they produced something that looked like a Java EE server, even if they were a bit lighter. But anyway, we still had how to say, slowness of some server in microprofile and stuff like that. So I think the lack of having an implementation of microprofile, or more implementation of microprofile from scratch, using whatever layer as integration of all the spec, let's say CDI, it could have been something like that, brought some limitation to the microprofile option. That again, it's my vision of the story. let's continue with the cloud war, which is, how to say, the current era. So 3 years ago, Red Hat released Quarkus. So I think most of you heard about Quarkus. So Quarkus was sold at the beginning as the cloud native framework, and it's of course more or less based on microprofile. It's an implementation. It's implementing microprofile, even if there are some glitches in this implementation, but they try to make it more and more compliant with microprofile specification. So the main focus of Quarkus was the cloud, and the main assets of Quarkus was to use the new virtual machine that was released, that was started a lot of years back, but that was released a few years ago, Graal VM, that allowed to generate static code and avoiding to create all the magic that was done in CDI, AGB, etc. At runtime, and this magic is created at build time with Graal VM. So that's the reason why Quarkus is produce very light binary, very efficient binary, can even produce platform binary thanks to Graal VM. And at the beginning, when Quarkus was launched, a lot of effort was pushed in the project. It looked like the effort that was made 10 years ago on the JBoss SIM, but with a lot more people. And this effort led to a creation of a very, very rich ecosystem. So today there are a lot of framework solution integrated with Quarkus by Quarkus team itself, and a few third-party editor that took on them to integrate their solution with Quarkus. And I think it was the first time during all this war that the J2EE side, the spec side, had an advantage and was in advance on Spring. Spring was always a bit earlier on a few stuff for a lot of reasons, and it's the first time that the spec, the microprofile Jakarta EE side was in advance on Spring. But of course, as you may know, Spring Boot its own answer to the release of Quarkus, and other initiative on Graal VM. There is not only Quarkus but other initiative. But Spring Native was the answer of Spring regarding Quarkus and usage of Graal VM. So it was released a few weeks ago, 1 month ago, 2 months ago, I guess. So it followed the same path than Quarkus. So it's cloud native. So it's use Spring framework. So it's very, very efficient, and everybody knows how to develop and knows the programming model of this Spring Native initiative. It has mostly all the ecosystem of Spring, even if there are a lot of work to do to make this ecosystem integration compatible with the Graal VM approach. And as I said in the previous slide, my feeling is that the first time Spring is clearly 3 years late. The release of Quarkus was in 2020, and how to say, Spring Native was released a few weeks back. So we don't know how it will come, but I'm not very how to say, I'm not very optimist regarding the Jakarta EE part and the evolution of the adoption, but I may be wrong. So to conclude, when we talk about war, is it war? That's my final question. So as you saw in the last slide, the war is going on. So it's restarted with those Graal VM initiative on both sides. So a war is still there, but is it really a war? If you look back, the competition between both sides benefited the whole Java for the enterprise ecosystem. So if Spring didn't come out, there would have been probably no HGB3 or CDI, or they would have been like they are today. So the competition is a good thing here. And the same for Spring Native. I think that if there wasn't a Quarkus release, the Spring Native wouldn't have been here right now, perhaps later or perhaps never. So you see that every move of one side make the other side innovate and add new stuff and new feature. And perhaps today in our cloud era, all the standards we are talking about have moved elsewhere. So if you look to all the feature we have to deal with on development today, you have a question about and standardization about containerization, REST API, JSON, cloud event, etc., etc. And that's all for me. So if you have questions, remark, it's now time.
Yeah, so let me just switch here. So yeah, thank you for the presentation. It's awesome. I think everybody in this ecosystem benefits from having a history lesson from time to time, so remember back what actually triggered all these things. So that was very interesting. And I also enjoyed the last comment you said, that it's maybe it's not a war, it's a good competition.
Yeah.
And it from time to time it has been like squabbling siblings, but I think now it's more brotherly love or whatever you call it. So the different kind of frameworks trigger each other and make each other better. So there are a couple of comments and questions. There's one about the open telemetry of microprofile. I don't know how much you're involved in microprofile.
I used to be. I'm less I'm less involved right now. It's hard to have a paid job and not paid to work on a specification. It's a bit hard to follow all the stuff. So I don't think I will be very relevant, very useful on the open telemetry. I'm sorry.
I think what they are going to do is to adopt the open telemetry from the Cloud Native Foundation and use that specification.
Yeah. That's what I heard.
Yeah. So, and then there are some CDI questions. And what is your forecast about the evolution of CDI? Will it keep on being important, or will it ever be replaced by something else? Or how do you see CDI moving?
No, I don't think it will be replaced by anything else right now, because it's the cornerstone of microprofile, and it became more or less one of the main integration point of the Jakarta EE stack. So I don't see it going anywhere. With the CDI 4 release, there is this CDI Lite part in CDI. CDI Lite part is a way to to standardize the extension we have in Quarkus. So on the paper, it should allow to create a new build time extension, because the portable extension, the legacy portable extension, cannot be used to create integration of third-party framework at build time on Graal VM. So we need a new way to extend the framework. So the CDI Lite initiative bring this new flavor of extension. It doesn't deprecate the existing portable extension. It's a new way to do extension. And if people using CDI Lite do the job, if those people do the job, we'll have a nice way to integrate third-party technology in CDI, and thus provide a consistent programming model for microprofile and for Jakarta EE on very light target with Quarkus, Micronaut, and other vendor that will adopt this approach. And even if you stay with something less fancy and less Graal VM oriented, you will benefit to have something lighter. So I don't think CDI is going anywhere now soon. It will go where microprofile and Jakarta EE will go. So their fate is linked now.
And the way it looks in Jakarta E11 is that CDI will be even more dominant.
So. Yeah. There will be more integration with JAX-RS. No, not JAX-RS, the RESTful web service specification. And it was a work that started long ago, 6 or 7 years ago. And I guess now I see that the at context was deprecated, and we will try to integrate, to have a better integration with the RESTful web service. So it's becoming more and more pervasive in both stack, I guess.
So would you say EJBs are successful nowadays?
I think EJB is. I'm very how to say, puzzled by EJB, because now it's rather nice specification. The problem is it was doomed by its name. I think that EJB3 should have changed its name. It's a bit silly to say like that, but the bad buzz on EJB1 should have led the specification leader to change the name or do something about it, because when you talk about EJB to most of people, they keep the legend of it's cumbersome, it's big, it's heavy, it's a nightmare to develop, etc. And it's no more the case.
No, and if you look at what is happening with the Jakarta discussions nowadays and with CDI, we're sooner or later going to go full circle and build in all these EJB capabilities in a CDI annotation and transaction report and everything. So well, let's see how it goes. So there is also a question: where do you think Quarkus or Micronaut will be in 5 or 10 years? Wow. And will they gain more traction, or will Spring continue to dominate?
You see, a few years back, I was discussing with former colleagues of me, and I predicted the return of the proprietary server, and I was more or less wrong and more or less right. If you look at Quarkus today, it looks like microprofile. It feels like microprofile, but it's still not microprofile. And to be honest, it gets a lot of momentum. It's roughly the same for Micronaut. I don't know Micronaut a lot, but so the problem I think with Jakarta EE, and I'm very sorry for that, is the fact that it's very hard to have a discussion and to have an agreement with a lot of people in the room. Leading a spec made me realize that. And you took a lot of time, and you made a lot of, how to say, middle decision to make everybody happy. So sometimes could be a good thing to try to go a bit aside and decide yourself what you provide as the implementation. That's the case of Quarkus. They decided to do a more proprietary approach. So they tried to make it compatible with the standard, but it's not totally. So I don't know. I don't know where they will be in 5 years. I think that if Red Hat stays at its is today, Quarkus will keep to have a great momentum. But in the past, they destroy nice project as well. So I don't know. I cannot say. But to be honest, I think it will be there as long as Spring will be there as well.
Maybe we should do this talk in 5 years, and then we can look back at this recording and see if you're right.
I will be thrilled to do that, and I will be very sorry to see me to see my past self to say such things. No, but to be more assertive, I think that Quarkus will continue and will have a great adoption, but I'm afraid it won't be the same adoption that Spring will have and Spring Native will have, I guess.
Yeah. And that kind of leads into the last question we have there, and that is, do you think Spring Native will catch up and even prevail over Quarkus?
It's a bit early to say, but I think it will. I think it will because people at Spring are a very good developer, and they have something that Quarkus has now, but they are late. It's branding. It's branding. It's a kind of marketing. You know, I'm working in a big bank right now on the big project, and it was very, very hard to convince people to adopt Quarkus. So we achieved that. But they were saying, why don't you use Spring? We know Spring. People we hire know Spring, etc. So we demonstrate that if you know Spring, in one day you can switch to Quarkus because the programming model is very similar. But they are still very suspicious about Quarkus. So they compared the framework to over very how to say specific and very small experimentation like Play framework. I don't have any problem with Play framework, but comparing Quarkus, which is an implementation of microprofile, with Play framework, demonstrate that you don't understand what you're talking about. But it's very hard to convince the end users, so the people that decide at the customer. And in fact, that's those people that made the success of technologies. So I'm not totally confident, but perhaps it's the way we see that in Europe and in France. Perhaps it's different in other countries. I hope so.
So what is your opinion to build a monolithic application with a microprofile or microservice technologies such as Quarkus?
To create a monolithic application in microservice? Wow.
In tech like Quarkus, create a monolith in Quarkus.
I don't think Quarkus is a good tool to create a monolith, to be honest. I don't see, because if you start with a technology designed to create microservice and integration through REST or a broker and stuff like that, you will have to recreate all the ecosystem that you had in a monolithic solution and a server platform. So if you really need to create a monolith, take a J2EE server. It will be easier, I guess.
Yeah. Well,
I don't know what's your opinion, Ivar, on
yeah, I agree with you there.
Yeah.
Fully.
In fact, it's always a question of the story of the golden hammer.
Yeah.
When you're an engineer, it's a risk that you have a very deep knowledge on the technologies. It's your golden hammer, and when you have a golden hammer, everything looks like a nail. But you have to you have to think against yourself and say, okay, I love this technology, but here it's not the right technology to go to this project. And I worked with a lot of people that weren't able to do that.
Yeah. So I think that was the last question. I had a great time. I hope you had as well. So,
Yeah,
any closing remarks, or should we just say this is it?
this is it. This is it. It was nice.
Yeah. Well,
Thank you. Even
thank
if
you.
I don't see anybody, thank you, everyone.
Yeah. Thank you very much, and see you later.
See you. Bye.